Hi everyone, welcome to our video on more multiple events with probability. So our strategy for these problems is usually to draw a tree diagram. So let's show how it works in this example. So in this example, Stan, that should be Stan, we'll change that. So on yours it will be fixed. Stan always gets McWindy's for dinner on Friday, Saturday, and Sunday. If McWindy's gets the order correct 80% of the time, what is the probability Stan's order will be correct at least twice in 1 week? Okay, so at least twice in 1 week. So that's special vocabulary. All right, well, anyway, so here we've got a case of multiple events. So he's ordering food from this made-up restaurant, McWindy's, 3 times in a row, Friday, Saturday, and Sunday. All right, so the way that we're going to break it down, though, so it's saying they either get it correct or they would not get it correct. Okay, so, and that's a good way to set up tree diagrams a lot of the times. It depends on how many events that are concerning to us, but often with tree diagrams, we do the event that they talk about and the complement of the event. So the way that I'm going to mark this is, let's make it over here, hopefully there's enough room, is that they either get it correct, so I'm going to use C for correct, and let's do, let me put it in blue, the probability. So the probability that they get the order correct is 0.8, which would mean, and I'm using decimals, so these should be converted to decimals in the tree diagram. All right, so the probability that they get it correct is 0.8, which would mean the probability that it's incorrect is 0.2. So I'm going to do complement. So C is correct, not the C is incorrect. Okay, so that's how we could break it down. All right, and then so this is like the Friday order. And then now we'll continue to branch. There's 2 of them, correct and incorrect, correct and incorrect. Well, it's 80% every time if it's going to be correct. So let's go ahead and fill that in. So 0.8 correct, 0.2 incorrect, and then 0.8 correct, 0.2 incorrect. And then a couple more. All right, so this is the Saturday ordering. Saturday, and then now it branches 2 more times. So correct, incorrect, and I'm going to go ahead and just fill all these in. Correct, incorrect, correct, incorrect, correct, incorrect. And these are the Sunday orders. Okay, so then again, well, it's still 0.8 correct chance, which means 0.2 incorrect. And then let's fill them all in. Okay, so often we have to write a little tiny on these tree diagrams. Okay, so there they all are. Okay, and then, well, just to do them, let's go ahead and write all of these out. Since we see at least twice, that's a special case. So I think it's best if we go ahead and just say, well, this is the probability that all of them are correct. So, and remember, you're following the branches. So correct, correct, correct branch. And then from there, we would multiply those probabilities. So the 0.8 times 0.8 times 0.8. And then from there, we'll wait and use the calculator in a second. Okay, so these are all the setups. So, and then this one, follow the branch, correct, correct, incorrect. And so there we go. And then following and marking those respective probabilities would be 0.8, 0.8, and 0.2. And then again, we'll wait for a calculator. Okay, so let's go ahead. I'm going to just start to mark all of these with the arrows, so for organization purposes. Okay, so the next one is the correct, incorrect, correct. And then marking those respective probabilities would be the 0.8, the 0.2, and the 0.8. And again, we could wait till our calculator. And then this 4th one is correct branch, incorrect branch, incorrect branch. So we've got correct, incorrect, incorrect, and then those respective probabilities, 0.8, 0.2, 0.2. And then keep it going. Okay, so these bottom 4 start with the incorrect. Okay, so incorrect, and then it goes correct, correct for this first one here. So that's your 0.2, 0.8, 0.8. So remember, I'm just following the branches and their respective probabilities. Then this next one, it starts incorrect, correct, and then incorrect. So 0.2, 0.8, 0.2, and then 2 more. Incorrect, incorrect, correct. So 0.2, 0.2, 0.8. And then this last one is all incorrect. Each day it's incorrect. Okay, so that's the 0.2, 0.2, and 0.2. Okay, so here they all are. And then now I'm just going to use my calculator on the computer, scientific. Okay, so 0.8 times 0.8 times 0.8 is 0.512. Okay, so I'm just going to multiply these out. And, I'm just going to maybe keep it to the side. There's that one. And then multiplying the next one, 0.8 times 0.8 times 0.2 is 0.128. And then here's where we might be able to catch a pattern. Notice this is the same. These are the same numbers, just in a different order. So that's 128. And notice it also happens if you skip one, it happens here as well. So that's 0.128. So this is kind of common with some of these problems. Notice these would be called independent events too, because the percentage or the probabilities for correct don't change from event to event. Okay, so anyway, so we've got those, and then let's multiply the one that I skipped. The 0.8 times 0.2 times 0.2 is 0.032. Okay. And then notice the next two are the same 0.2, 0.2, and 0.8, just in a different order. So we can go ahead and just copy what we just did. And then the last one is 0.2, 0.2, 0.2, which gives us 0.008. There they all are. Okay, so those are all of the probabilities that are important to us. All right, so at least twice in 1 week is now what I need to decipher. Okay, so let's go ahead and mark that in purple at this point. So at least, it will be correct. Let's underline all of it. So it will be correct at least twice in 1 week. So the at least twice, okay, so or the at least part, twice. So at least, or you could say at least 2 times, if that helps as well. So twice is 2 times. Remember, at least is saying 2 is the least. So this is being correct. Correct 2 or more times. Okay, so that means I want to go through all of the ones that are having 2 corrects or more. So that would be this one. This one has 2 corrects in it. This one has 2 corrects in it. And then that one doesn't, but this one does as well. So let's go ahead and just box them. Okay, so there's 4 of them where there are at least 2 corrects. Okay, and so that means when it really comes to an OR problem, so this is one event that could have occurred with its probability, or this is one of the final outcomes that could have occurred, or this, or this. So any of these are the ORs that could have happened. And in our cases with these tree diagrams, with these multiple events, the OR part is telling you to add all of those probabilities for the final answer. So the probability of at least 2 times, let's go ahead, correct, at least 2 times correct, is equal to the 0.512 plus the 0.128 plus the 0.128 plus the 0.128. So there's 3 of them. Okay, so that means when I go to my calculator, I can add all these up now. So 0.512 plus 0.128 plus 0.128 plus 0.128. Okay, so 0.896. And so let's write that as 0.896, and then maybe we can convert this one to a percent since it started with percents. So it's about a 90% chance, so 89.6% chance that the order is correct at least 2 of the times out of the 3 days that Stan orders here. Okay, so there's our special case there. So again, the tree diagram gives you all of the information that's important, and then still up to us to figure out how to dissect it to know what to take from it and how to finish it off. Okay, so that's one. Let's go ahead and pause. I'm going to do this in a different video to finish off my last multiple event problem. Okay, so if you feel good, I mean, maybe take a break, but all right, that's going to be it. So we'll come back in a minute. Thanks for watching, and I'll see you again soon.